Hi guys, welcome back to another video. I know it's been a while, but over the summer I worked on a big Heuer vise and I tried to repair the slide, and this is what this video is about, trying to repair the slide on an old Heuer vise. So this time it's in front of the computer and I'm trying to explain what I found out and what you could do to fix it. So let's start with a picture of the patent from the vise, and you see the dynamic jaw right there. It moves back and forth on the slide down there, and over the years, let's say 50 years, dirt and grit gets into everything over time, and it kind of works as abrasive and wears down this part here, and it does that on the static jaw and on the dynamic jaw. So if you look at a mint Heuer vise, the dynamic jaw should look like on the left side here. So we have mint contact areas on the top the tube, and on the bottom the slightly bigger ones are straight as an arrow. But if you look at a worn out one, the bottom will kind of look like over here on the right side. You have a worn down contact area, which is this part here, and a mint or not worn down part, which is the area that doesn't contact anything. So you would think, okay, I'm going to weld this up. So you're going to weld this up with some weld, like so, and that should fix it. Or I'm using a shim and just brace this on, or maybe just bolt this on. Let me bolt this on, like so. Put a bolt in here, right? Just so, like so, and it's on there. But as we saw before, the static jaw is also worn down. So if you look at the mint static jaw at the top, it looks very good. And an old used one, we have a drop here in the slide. We have a drop and it's worn down here. The front and the back are usually fine. Of course, it's not sliding there that much, so this area is good. So that means that if you only do this fix, which is doable by hand, you weld this up and then you file this down and use this surface as reference, or you machine this down and use this surface as reference, this part here, this not worn down part, then it will still be sloppy. So because while it would be tight here and there, it won't have enough contact area to not be sloppy in the middle, and if you tighten it up with the bolt to compensate for that, it will get stuck at the back. So it doesn't make any sense, it doesn't really do much. So you really need to fix the static jaw first. And with a mill, if you look, we have the feet here. We have feet here and there, and these are machined. So these are our references. You just clamp this to the table and then you can machine away good metal. Unfortunately, we need to remove good metal and get it down to this level here. So we remove the good green metal here and make it all as bad as the middle is. And with the mill you clamp this down, and then you just can use the top as a reference. It should be okay, the top, to get left and right, get this align, and then you machine this. You should check the top first. Sometimes there are little spots, but it shouldn't be worn down, because if that is also worn down, then you don't have much of a surface to go against. You could probably use the side then to get everything aligned. And if you don't have a mill, if you just use manual work, just use a file. What I did, I made myself a template, like a wooden template, which looked like the dynamic jaw, like so. And this template, it fit in here, but at the middle, where it's the widest, where the distance here is the widest, and of course it would get stuck at the front and the back. And I filed this down and that down, and also used the rule to check if it's straight, if this whole thing is straight, until my wooden template would fit also at the front and the back. You need to have a very narrow file to get in here and not hit the button. So it wasn't easy. It's not easy to do it, but it's kind of doable. And also with a mill, you get probably both sides the same height to the bottom. And if you do it by hand, it's obviously not really possible to get it really exact, but you get it kind of where you want it to with a lot of work. So yeah, fix the static jaw. So now the static jaw is fixed. We can go back to the dynamic jaw. First thing we need to do is make sure these both surfaces here are parallel to each other, because the original design used the bolt coming from here. Right, the bolt would screw in here and pull both sides together to compensate for slop, and this would deform the vise permanently. So after a while, these both surfaces aren't parallel, but they look like that, and you need to fix that before you do anything here. So how can you do that? It's very simple. You simply put the bolt in from the other side here. Put it from this side. Oh, sorry. So, and it sticks out like so. And you put on the nut to protect the threads there. Put on the nut like so. And then you just put a metal plate here. And now you can tighten up the bolt with a lot of force. This will push the jaws apart, and you do it so you push them apart too much, so that with the rebound they are back to being parallel to each other, more or less. So once you have both sides parallel to each other again, then the question is, how do we get the height correct? So if you look at the worn down part there, this is supposedly the original height there, and this is the worn down part. And if you measure the distance between the original at the front and the back to the lowest point here from the drop, that is as much as you need to add back on. But you can also do a different way, and that is, we have this distance 1, and we have another distance 2, and distance 2, D2, is smaller than D1, which is obvious because you need to have a gap here to be able to clamp both sides closer together to compensate for slop. So if we imagine the dynamic jaw being on here, it would be like so, right? That is the dynamic jaw, and there is a gap here which is half the difference between D1 and D2. So you need to measure the height here. Let me draw this in. You need to measure the height. This is the height at a distance of half the difference between D1 and D2, which is kind of around a millimeter, but you need to just calculate that and then measure. And this is the desired height we want to have here. So this is the height we want to have. So once you have the height, you can build up the worn down part. So you weld this up and you weld this up, and then you add some more over here so it looks good. If you just weld up the inner part, you have a step here, you don't want it. So You can do that. And if you want to do a shim, if you have a mill, you could machine it down to like so, and then put a shim on of the correct thickness, and then machine it down, bolt it on again. You could brace it on, but let's bolt it on. Okay, so once you have built it up, now you need to machine this or file this down, and now you would think, okay, I use the top slide area as reference, but that doesn't really work that well, because if we look on the side of the dynamic jaw, so these are the contact areas, this is the bolt hole, they should be parallel to each other, and we could use the top. But in reality, on a worn down one, so this is the worn down contact area we just built up, right? And if you look at the top, you will see that this is also mangled. Why is that? At the back, I don't know, but the front is kind of understandable, because if you look at a vise, at a back opening vise, you always have the force from the lead screw going to the nut, and from the nut it goes upwards to the jaw and clamps the workpiece. But due to this angle here, you also have an upwards force which tries to pull or push the dynamic jaw upwards. You see this on every back opening vise. It's always there, which also means that this area here will take this upwards force. It will come on this area, and the back bottom one is the pivot point. So it kind of pivots this way, and this area here stops it from doing that. And that is why over time the front gets worn down here, this area. So you only have the middle where it's kinda okay. We can use the middle to get our height here. We can measure that. This is the height there, and we know how much to add to our worn out area. But of course, for machining this is no good. So I tried to find a different surface. So if we check the surfaces here, we have, first of all, we have this surface, which is the reference for the angle. So with that we know this is 15 degrees, so this angle is 105, and we get the angle right, and don't mess that up. The outside is no good, but this area is fine for the angle. And for the height, I found out that this and that area, they are good. Not the middle, don't use that one, that kind of drops differently, I don't know why, but you can use these two areas to align everything, because this area is no good. You can't use that one. And if you do it by hand, I made myself a wooden template that would touch the top, then go down here, and then over here. So I would use it to get the 15 degrees right and get the height correct. So these surfaces are fine, except for this area here. Due to the hole for the nut, there is the metal is quite thin there, like almost not there, and it kind of creates a bump. So there's a little bump where the nut is. Otherwise it's okay. So with this you can machine down the build up to the correct height, which you either just calculated with the mount you removed here and added to the unworn part. This is one way to do it. Or you just measure a fresh height at the correct distance and use that one for the new height of the dynamic jaw. And if everything works out correctly, like these are the same distance from the bottom, and these are the same height on both sides, then when you put on the dynamic jaw back on the vise and close it, this should be flush at the top. And if you look from the side, of course the sides should be flush too. That is all there is to it. If you do it by hand, it's quite a lot of work filing this down. It's not easy. And also getting this 15 degrees right with a file is not easy. It's a lot. As I said, I used the wooden template to get this all kind of 15 degrees and touching here to get it the same height over the whole distance so that this is straight and not has a bow in it. Use the straight edge too to check this. But with a mill should be quite simple to do, and you can always weld this back up and try again. You have not only one attempt, you have a few more attempts. For example, I welded this on in the first try. It didn't keep me that reference surface. I was stupid. I did this in the first try already, and then I noticed that this surface is no good, and it took me a while to figure out I could use that one. But I forgot to fix the static jaw, so I filed down it so much I could pause the good part, and of course it was sloppy again after when I reached that area. So I had to weld a second time, build it up more, and then the second time I fixed the static jaw first and then put on the dynamic jaw, and now it's good. So that's why I make this video, so you don't make the same mistake and make yourself a lot more work than you need to. So we have the easy fix you can do quickly, just by hand, and maybe it's enough, but if it isn't enough, then you need to do the whole thing. So I'm going to try to cut the video for the big vise, and until then, see you next time.